Hello, I'm Micky Costa. Today I'm presenting my solo final project on multiclass sentiment classification using the Yelp review full dataset. I want to start by extending a huge thank you to my professor for providing access to this high-end Azure VM equipped with an NVIDIA Tesla V100 16GB GPU. Because this is a professional grade, time limited resource, efficiency was my top priority. In cell 1, I tried to initialize the environment to ensure torch and accelerate were properly linked to the V100's CUBA core, allowing me to take full advantage of its tensor core acceleration. In cell 2, I set up my technical fail-safes. I explicitly adjust the HF hub read timeout to 120 seconds. And working on a powerful remote VM means protecting the station from network instability. These settings ensured that loading the massive Yelp dataset wouldn't time out, which would have wasted precious GPU uptimes. In cell 3, I addressed the requirement for custom data filters. I developed a function called clean text to serve as a noise reduction layer. It use regular expression to strip out HTML tags and normalize all text to lowercase. By filtering out this digital noise, I ensured the V100's 16 GB of memory was occupied by meaningful linguistic data rather than irrelevant formatting characters. In cell 4, I utilize the DistilBERT tokenizer to convert human reviews into numerical tensors by selecting a uniform maximum length and padding the sequence. I created a consistent data structure that allows the Tesla V100 to process batches of reviews in parallel, maximizing the throughput of the GPU. Moving forward to cell 5, where I choose DistilBERT-base-uncased. This was a strategic choice for a solo project. It provides 97% of the performance of BERT, but is much more memory efficient. This allowed me to perform a fine full tuning of all 66 million parameters within the time limited window. I also configured the trainer to limit a saved model to one proactively managing the VM disk space. Moving forward to C6, where execution happened, where I like to thank the raw power of the Tesla V100. The training completed in just 984.42 seconds. The V100's architecture allowed the training loss to drop steadily from 0.94 to 0.63, providing that the model was successfully converging at a high speed without any hardware bottleneck. Moving forward to cell 7, where I evaluated the model on a 5,000 unseen review, achieving a weighted F1 score of 0.6176. And the confusion matrix shows the model is highly accurate, and the polar extreme of 1 and 5 star, while there is a minor overlaps in the 2 to 4 star range, reflecting the subjective nature of human opinion. The error are almost exclusively off by 1. This demonstrates that the model understands the gradient of sentiment, which is a major success for a solo effort. And moving forward to my last cell, where I tried to save my fine-tuned weights and created the zip file. This ensures my work is preserved even after the VM session concludes. Again, a sincere thank to my professor for V100 access that made this possible. This is Micky Costa signing off.